I'm Neil Tinmouth. I'm the Chief Operating Officer of Seekit International. The ocean drives the global systems that make our Earth habitable. It's also the mainstay of a global economy, contributing $1.5 trillion and 31 million direct full-time jobs. However, ocean health is declining. If we want a sustainable future, we need to ensure better stewardship of this global resource. Despite being critical to our existence, we know little about what lies beneath the waves. As of June 2020, only 20% of the ocean floor has been mapped. This is changing. With the establishment of the UN Sustainable Development Goals and initiatives like the Nippon Foundation Geography2050 project, we are now taking steps towards addressing these challenges and building a more sustainable blue economy. However, to achieve this, we need data. Traditionally, this has required large, expensive vessels which burn tens of cubic meters of diesel every day. Large vessels also require a large complement of crew, which need to be changed out frequently, resulting in hundreds of flights per vessel per year, adding to the already heavy operational carbon footprint. But this is all changing. With recent technological advancements and innovations in sensors, satellite technologies, and autonomous systems, we are now able to collect unprecedented amounts of ocean data more cost-effectively, with a smaller carbon footprint and without putting people in harm's way. Our recent 22-day uncrewed Atlantic mission collected 1.5 billion data points. Being uncrewed, naval architects can completely rethink the way we design ocean-going craft. Without the need to accommodate crew, vessels can be designed around payload, sensor requirements, making them smaller and more power efficient. The result is vessels can cost as little as 5% of a traditional vessel, whilst producing only 1 to 5% of the carbon emissions. For projects like Geography2050, which aims to map 100% of the ocean floor, this will have a massive impact on feasibility. Mapping at depths of over 200 meters could take up to 127,000 vessel years, costing over $3 billion and generating millions of tons of carbon. A fleet of smaller, specially designed uncrewed surface vessels could be built and operated at a fraction of the cost with a much smaller carbon footprint. The need for uncrewed solutions has been further highlighted with the onset of COVID-19. With many countries on lockdown, it is a logistical nightmare to get crew to and from the vessels. Consequently, whilst many field research activities have been placed on pause, the US sector has seen a rapid growth as vessel operators and research institutes look for innovative solutions to maintain business continuity. Companies operating uncrewed vessels have been able to continue with minimal disruption as operators control the vessels from the safety of the onshore remote control center. Despite the pandemic this year, we have managed to complete 2 large-scale projects. However, to get to this point, there's had to be a major step change in technology, regulations, and industry mindset. For a USV to operate safely and interact with other vessels offshore, operators need to be able to sense what is happening in and around the vessel. Rapid development of connected sensors now allows operators ashore to monitor the vessel and the surrounding environment to make real-time decisions. As sensor technology has matured, they've become more robust and accurate while prices have decreased. However, as we get an increase of sensor uptakes, it comes with its own challenges, including the increased amount of data which needs to be communicated between the vessel and shore. Vessels operating over the horizon are dependent on satellite communication to transfer situational awareness information from the vessel to the operators, where they assess the information and then send back the appropriate command and control signals. The increase in demand of global connectivity means satellite communication has come a long way. Historically, these systems have been extremely expensive with limited available bandwidths, but in recent years, costs have come down by as much as 60%. Costs and bandwidths are set to improve further with LEOSAT systems, which should bring the cost of high-speed offshore data services in line with terrestrial connections. Regulations often struggle to keep up with the pace of innovation, and technology gets tangled in red tape. USV developers and operators must often find novel ways to fit within the existing frameworks. But this is changing as regulatory bodies begin to see the value of uncrewed vessels and increasingly support companies by providing flexible frameworks to safely test and demonstrate the capabilities. Since Seekit was part of the winning GEPCO Nippon Foundation alumni team entry in the X Prize competition, we have seen a rapid increase in USV capabilities, including the development and deployment of more complicated systems such as ROVs and AUVs. However, there is plenty of room for continued development before we see USVs becoming an industry norm. So what does the future of USV technology look like? To accommodate the ever-increasing volume of data being collected, there will be a growing shift towards edge computing and AI data processing, along with improved autonomous functionality and capabilities, including collision avoidance. This is already becoming a reality with the development of systems like Teledyne's Mira AI, which was used to process multi-beam data on board the vessel during our recent Atlantic mission. Uncrewed vessels are set to play a prominent role in the future of marine survey and inspection, and we're starting to see wider adoption. Remote technologies will deliver significant benefits to everyone involved in the marine sector, bringing about faster, more efficient, and safer marine operations at a more sustainable scale.